Hi everyone, welcome back to yet another smart contract, yet another exciting smart contract development tutorial. In this tutorial, we are going to build a ERC. We are going to implement ERC 4626, which is a tokenized standard for Ethereum that was introduced in 2022 to standardize yield-bearing tokens in DeFi or alt interactions. We are going to build it from implement and build it from scratch. We will build a simple vault and I will show you there how you can implement ERC 4626 smart contract. We will build it from scratch, we will test it and we will deploy it. I split this video into two parts. In this part we are going to build smart contracts only, and in the upcoming parts we are going to test, and we are going at the end we are going to deploy it on Rootstock test network. So if you want to learn about Rootstock, you can go here. As a developer, you can go to docs and learn about the Rootstock, and it's you can explore its comprehensive documentation. And also make sure you added the Rootstock testnet and mainnet to your MetaMask or the whatever wallet you are using. To add, you can go here and search and search the MetaMask. Here you can see configure MetaMask, and by clicking these two buttons you can add the Rootstock networks. You can see here I have already added the Rootstock mainnet and Rootstock test network. And so what is the let's get ahead and let's understand briefly. I will give you a brief intro of what is ERC4626 and why we are going to build here. So it is very important to understand. So what is ERC4626? ERC4626 is an extension of ERC20 token standard. I hope you know what is the ERC20 token. I also created a video of ERC20, how you can build it from scratch, how you can test it, and how you can deploy it on blockchain. So what is the ERC20? ERC4626. So it is the extension of ERC20 token standard that creates a unified interface for tokenized vaults. And you can think it as a standardized way to wrap yield generating strategy into token that users can easily interact with. And what problem it actually solves, and why we care about this. If you remember, before ERC, every DeFi protocol had its own way of handling deposit and withdrawals and yield calculation that created that created a very like integration complexity for developers, inconsistent user experience, and difficulty in composing different yield strategies. And it also higher gas codes due to custom implementation. And now let's see what are the key components. The key components of C4626. The first and important is vault token. The ERC26 token represents shares in the underlying vault strategies, where when you deposit asset, you receive all tokens proportional to a share of the total pool. And the underlying assets, the base token that alts accept, like USDC, DAI, or the Ethereum, which is JIT. And now, what are the core functions that standard include function for? You can deposit and mint, adding asset to the vault, withdraw and redeem. And what are the real world applications you can build using ERC4626? And ERC462 vaults are used for yield farming strategies, lending protocols, taking derivatives, portfolio management, risk management strategies, and so on. And there are a lot of benefits of the 4626, and in this video we are going to build very simple alt. I will show you how you can implement this, and we are going to use Foundry for which is the blazing fast smart contract development tool. And since Rootstock is fully EVM compatible, you can use same Ethereum tools such as Foundry, Hard Hat, and same languages, and you can take also if you go here you can learn about the Rootstock, which use merge mining and Bitcoin's hash power, how merge mining happen. You can go how PowPegs, how what is merge mining, what is PowPeg. You can learn about this here, and you can using Ethereum's compatibility and Bitcoin security, you can literally build phenomenal application on Rootstock network. So without wasting a time, let's jump into coding and start building our smart contract. That Here I am on my desktop. Let's create a new folder here. Let's name it simple vault and open it in our VS Code. There we go. It is opening, and yes, I trust authors. Welcome, and open our terminal. Let's of this. Let's initialize our Foundry project by running this command forge init, and we are also going to use OpenZeppelin library for developing this smart contract. We are going to follow some of the best security and gas optimization practices as we have been doing in the previous tutorials. So let's go ahead and let's install OpenZeppelin by running this command forge install OpenZeppelin slash OpenZeppelin dash contracts. Hit enter, and let's wait while it is installing. And while it is installing, let's delete these three files as we always do. Counter.s.sol and the script counter.s.sol. There we go. And let's create a new file inside the source directory. Let's name it simple vault. This is what we are going to build, and there we go. It is still installing, and you can see here our OpenZeppelin contracts version 5.3.0 has been installed. And let's set remappings or remappings dot txt. By the way, you can set your remappings here in foundry.toml as well, but this is what I do and you should do. This is the best practice. Forge remappings.txt, and it will automatically generate remappings.txt by setting our remappings. And this is what for to avoid some red lines from our VS code or the code editor you are using. So let's start writing our smart contract. Fragma solidity, let's say license. We are going to use the 20 version 0.8.20. Let's go ahead and let's import. Since we installed OpenZeppelin, let's import whatever we need. We need whatever the smart contract libraries we need. Why it is invalid version for expected to reach out of Fragma. It is just VS Code error. So we gonna import ERC20 smart contract from OpenZeppelin. We also gonna import ERC4626 smart contracts, and our smart contracts will be ownable. And for the security, we are going to import reentrancy guard and interface for our smart contracts. So let's import this one by one. First, let's import ERC from. By the way, this is the named import. We are going to follow the best practice. OpenZeppelin contracts slash token slash ERC 2020 slash 20.sol. Let's import ERC 4626 from OpenZeppelin contract slash token ERC extension. As I said, ERC is an extension of ERC, and let's now import ownable OpenZeppelin contracts slash access and ownable.sol. Let's import reentrancy guard from OpenZeppelin contracts, not I think security. It is the utils reentrancy guard.sol. There we go. OpenZeppelin contracts utils reentrancy guard.sol, and we also need to import interface IERC interface. Import IERC20 from OpenZeppelin contracts slash I think interface and interface slash I interfaces slash IERC. Let's copy this from here. IERC20 dot IERC OpenZeppelin contracts slash interfaces slash IERC20 dot. So there we go, and let's start our smart contracts. Our simple alt allow user to deposit. So what we are going to build, we are going to build alt that allow users to deposit underlying ERC20 token and receive their alt shares. As I given the basic introduction of EIP 4626. So let's start building. contract. Let's name it simple alt, and which is uh, ERC 4626. It is also ownable that we are importing, and reentrancy guard. That's it. Now let's first, I think we need to set up our constructor. Let's construct, because if we do not set, it will throw us, and it will give us some red lines. So let's first set up our constructor, and after that we will declare some state variables. So let's initialize our constructor here, and inside that constructor, let's first we are going to take some arguments. So let's take IERC20, and let's name it asset. Also we need to take name, symbol, and some management fee. So string memory name, string memory symbol, and also we need to take some fee. So fee in the event 256 management fee, and here we need to call 4626, and inside that we are passing first only the asset. Think, yeah, asset. And now here we need to also call ERC20, and inside that ERC20 we need to call the name and the symbol. There we go. And also we need to make it the constructor ownable, and inside that we need to pass message dot sender. And let's try formatting this, and there we go. And let's write inside the constructor body. Let's first check here require and add condition. The management fee should be we need to declare here some first state variable. So let's add state variables. So I designed this smart contract and my like let's first declare the first constant variable unity 256. Let's make it private and constant, and let's first let's name it initial exchange rate. Initial exchange rate, and let's say 1E18. This is how you declare this in smart contracts, which is the 1 initial state. Now let's declare the management fee and last fee update. Right. So let's declare this one by one. Now this time we have to make it public, which is the management fee. Let's not initialize this here. We will initialize this in the constructor. And now let's also declare Unity 256 public last fee update date, and it is also we are not going to initialize. Now inside the constructor, let's add a condition. Management fee, which is we are taking here argument, should be less than or greater than, let's say, 1000. Otherwise we will revert an error, fee is too high. And now let's go ahead and let's set up this management fee, initialize this management fee to this management fee we are going to take, and last fee update we are also going to initialize last fee update as in block dot timestamp. Now before going ahead, let's format, and we have state variables, we have constructor. Let's also declare here, so we have not go back and declare. Let's declare some events here for management fee updated and fee collected. So I think Copilot suggested as the right or little bit the wrong. Let's say here new p, and let's add another event here. So we should not go back and collected. We will emit this events and event to 256 and amount. Let's format this, and now we are good to go. Let's first declare our very first function, which is the total asset. Let's go and let's write function total assets. Let's make it public and view, and we are going to override this. I hope how we are over. I hope you got and you have understanding how we are overriding this, because we installed OpenJBlin and we are inheriting smart contracts. So let's returns Unity 256, and we are going to return not total assets, but here we are going to use our ERC20 interface, and inside that we had to pass the asset and balance of address. This, there we go. Copilot suggested us the same. So I hope you got to know, you got it how we are passing this here. So we are returning the 20, which is the interface and the asset and the balance of this address. Now let's deposit asset and mint shares to receiver. For that's right, this function, let's name it deposit, and it will take an argument of parameter of Unity 256 of, let's say, assets and the receive address of the, let's make it public, override, and now this time we need to make it non reentrant, and it will returns what it will return, the shares. It will return the shares. So shares, you int 256, let's name it shares, and let's go ahead and write our function body. Here we are going to add the condition require the assets should be greater than 0, or we will revert an error, cannot deposit 0. What's wrong? Yeah, we forgot to add comma here. That's it. Now let's add another condition here for the receiver. The receiver not equal to address of the 0, otherwise we will add here invalid. So we are following CEI, which is the best smart contract practice, check effect interaction, and here we are going to call collect management function, which we will write after. So let's collect management fee. We will create this very soon, so don't worry about this. It will throw an error and need, obviously, so don't worry, we will it will go away. And now let's add this shares is equal to, here we are going to use the Solidity super keyword super dot deposit, and inside that deposit we are going to pass assets and receiver. We call this function, calling this the same function here, and now I think we done with this. Yeah, and let's go ahead and let's start writing our mint function here. Before writing this function, I think we need to create this function that is throwing us an error, so we can not get any. Let's get rid of these errors. First, let's write this one, which is our internal function. Let's make it internal, and function, what is this? You mean to add public internal? Let's make it here functions, and let's write this function first, and after that we will write our other functions. So here let's follow if management fee is equal to 0, we need to, let's not add a body, return, and let's go ahead and take an local variable Unity 256 of time elapsed, and let's say log dot timestamp, and we need to minus last p update from here, and let's add the condition here if time elapsed is equal to 0, and let's add the return format, and there we go. And now for total, let's add for total supply. Let's take a variable here, local variable UNT 256. It will shadow us because we have total supply function in ERC20 smart contract. Let's make it and dash is equal to total supply, and let's go ahead and add the condition here. If total supply is equal to 0, and we will add the body. Last fee update is equal to block.timestamp, and we will return this one. There we go. And now let's go ahead and let's calculate annual fee in basis points. For that, how you can create, let's take another local variable here, and let's name it annual fee is equal to total supply multiply management fee. I need to divide this, let's say 10,000. Now let's go ahead and let's calculate fee for time elapsed. Let's assume this 365 days per year. And how you can do, let's take a variable, local variable here. The amount is equal to, copy this annual fee here, annual fee multiply whatever the time elapsed, and here let's take divide this 365 days. And now let's add a condition here, last condition here. If fee amount is greater than 0, call the mint function here, which we will write, and owner, need to pass the owner, and the right side you need to pass the fee amount. Let's go. And last fee update is equal to block.timestamp, and we need to emit an event fees collected, which we already written here, fees collected, and inside that we are passing with fee amount. Let's format this, and now let's go ahead and we gonna write a lot of function here, so bear with me if it is not making sense to you. And we need to now write the mint function. So let's go ahead and after this internal functions, we have here the public functions. Let's comment this down, public functions. We return so far total asset deposit, and now let's write the mint function here. So let's go ahead, function mint, and it will take, I think, yeah, it will take the shares and receivers, the two parameters. So let's take this UNT 256, let's name it shares, shares, and address of the receiver. Let's make it public override non-intent. So let's copy this from here, and it will return what? It will return asset, it will return asset. So let's copy this from here, everything. Let's make it assets, and now let's write the functions body. So let's follow first, let's add some condition here first. By following CEI, shares should be greater than 0, or it will throw an error, cannot mean 0. Let's add another condition, require a receiver address and invalid receiver, and there we need to receiver address should not be address 0. The co-file it is. Now let's call here collect management and asset super.mint shares and receiver, and there we go, we almost done this. And now let's add the withdraw function, and we will add read management function. So first let's add the function for withdrawing, function withdraw, DRW withdraw, which will take parameter of asset receiver and owner. So let's take one by one. Int 256. First is 2 assets, and receiver address of the receiver, and also address of the owner. And let's make it public override non-rent, and it will also receive. Let's make it public non-rent, and it will return the shares. Now let's write the functions body here. Let's format this, and by following best practices. Let's add two conditions here, which is the same conditions. Require assets. If assets are less than 0, we will revert an error cannot draw 0, and require address, which should not be 0 address, or we will revert invalid receiver. And now let's call here the collect management fee, and shares is equal to super dot withdraw asset receiver and owner. Now let's go ahead, and for redeeming shares for assets, we are going to write the function. Let's make it, it will take in three parameters. First asset, shares, receiver and owner. So first you int 256 shares. First parameters is shares, and rest of receiver and owner. So let's copy this from here and paste here, and there we go. And it will also, we need to make public override non-intent, and it will return the asset. So let's copy this from here and paste it here. Let's say assets, and now let's add you int, I think there is the error, you int 256. Let's add two condition here. Require, the condition is shares should be greater than 0, otherwise it will throw an error, cannot mean 0. Right, now let's add the receiver address here, the same condition. We are going here, let's format this. Now let's add, let's call college management assets super dot redeem shares receiver and owner, and let's go ahead and create a set management fee function to update management fee, and we are going to give this access to only owner. So let's write this function set management fee. It will take an new fee parameter, and let's make it external and only owner. How only owner comes? Because we are inheriting this from OpenZeppelin. Now let's add the require, the condition here, new fee should be less than or is equal to 1000, otherwise we will revert an error, fee to high. And let's call here collect management fee, and now let's go ahead management fee, let's set the new fee, and we need to emit an event management fee updated, which we have declared here. Right, now all the errors and warnings are almost gone, and now let's add another function here for collect management, another external function here. So function collect management fee external, and let's make it not on in front, and we are calling this collect management fee function here. Now already we return some internal and external public function. Now let's go ahead and write some emergency withdraw functions, which only owner can do this. So for that, let's go ahead and let's first write for emergency withdraw, the function for emergency withdraw. Function emergency withdraw, and so how much amount the only owner wants to withdraw. So let's take an amount here, and let's make it external, and also only owner can do this. And now let's add the condition here, require amount should be less than or is equal to total assets, and inside, if it is not like this, we will revert an error insufficient as not funds. We have to pass insufficient assets. And now IERC20 asset and transfer, we are going to, there are two types of inbuilt functions, save transfer, but we are going to transfer here, use the transfer here. Let's first pass asset. I think we did something something wrong here. ERC20. We need to pass asset dot transfer we are going to use, and inside that transfer let's pass the owner, and now here we need to pass the amount, whatever the amount he want to transfer. And now I think, yeah, we did. What's wrong? Enter error. Yeah, there we go. We done with this error, and now we did emergency withdraw. Now let's write our last function, get alt info, which is important. So how this is optional and important, get alt information. So let's write function get vault info, and let's make it external view, and it will return a lot of things. It will returns address of the asset address, total assets, total supply, exchange rate, management fee, and so on. So let's return one by one. Now let's first address, that's first address asset address. Now let's also int 256 total assets and total supply. It will shadowing, that's why we are adding the dash here. It will also return exchange rate, and it will also return management fee. So you int management fee, and let's make it, what is the wrong here, trailing comma parameter list, format this. Now let's write the function's body here. Asset address is equal to asset, let's copy this from here. Asset address is equal to asset, and total assets, copy this from here. Total assets is equal to, we have total assets, we also have total supply is equal to total supply. And now exchange rate is, here we have to do what we have to do, total supply, or the total supply is equal to, if it is equal to 0, we need to call, sorry, if it is like this, initial exchange rate, we have the initial exchange rate, the constant variable. Otherwise else total assets, sorry, yeah, total assets multiply 1E18, some syntax error, so that's 1E18, and we need to divide this into total supply. There we go. And management fee is equal to management fee. And we done with our smart contracts. Actually, so far what we have done, we initialize our Foundry project, and we imported these libraries from OpenZeppelin. After installing OpenZeppelin, we declare some state variables. We have some event, we have two events here. We initialize constructor, we have public function for total asset, deposit, mint, withdraw, redeem, and we have bunch of other functions, set management fee, which we are giving only owner access. We have internal function, conduct management fee, and we have emergency withdraw, and we have get alt info function here. So if you go here, let's try compiling this. Let's clear it, and let's run this command for build. I'm making spelling mistakes or build, and you can see here compiler runs successful, which means smart contracts is compiled successfully. And I hope you enjoyed this tutorial and this part of this ERP 4626 smart contract implementation, which is our very basic simple vault we are going to deploy on Rootstock network. And in the next part, we are going to test entire functionality of our smart contract, and at the end we are going to deploy it on Rootstock test network. So thank you for watching again, and I will see you in next part. Bye bye.